Hello and welcome to this video out of my networking basics series. I'm Wolfgang Tremmel and I run the DE-CIX Academy. If you're interested in more videos, just head over to the DE-CIX website and have a look at my academy content, videos, recorded webinars and white papers ready for you to download. Okay, let's get started with today's topic, where I talk about global IP routing. In the last video of the Networking Basics series, I talked about IP addresses, prefixes, and routing in general. Today, I wanted to a bit more emphasize on how global IP routing works, also what is peering and why is DE-CIX and other internet exchanges so important to keep the internet together? Let's start with a quick recap of the IP, the Internet Protocol. With the IP layers, with the layers of the whole Internet Protocol stack, you know that the IP layer, the IP protocol, is on layer 3. Layer 3, the data units are called packets, and the purpose of layer 3 is, of course, to provide source to destination end-to-end transport. So from here to Australia, from here to the US, from here to anywhere in the world where you want to send data. And of course, the IP layer needs addresses. Each entity, each host, each smartphone needs to have an IP address to do IP protocol, to transport data via the IP protocol. And for this, we have two types of addresses. And let's not talk about addresses, let's talk about prefixes. A prefix, an IPv6 prefix in this case, is just the network part of an address. So in this case, we have here a /64. That means we have 64 bits in the network part of the address. The whole address, of course, is 128 bits long, and the notation is well known, the hexadecimal numbers separated by the colon. And the double colon at the end means fill up the rest with zeros. The prefix length in IPv6, of course, can be between 0 and 128, as the whole address is 128 bits long. Also, in a prefix, very important, the host part is all zeros. Otherwise, it's an address. A prefix written with the slash and the length of the network part, and the host part is all zeros. That's an IPv6 prefix in this case. For IPv4, of course, we also have prefixes written in the standard IPv4 notation and just 32 bits long. So the address is 32 bits long, of course, and the prefix here, we have a /22. That means we have 22 bits in the network part. The notation, decimal numbers separated by dots. The prefix length, of course, can be between 0 and 32 bits. And also here, the host part is all zeros. Another important point is that in IPv4 and IPv6, the boundary between network part and host part can be anywhere. This is the reason we always write it down. We write here /22, in this case, an IPv4 prefix with 22 bits in the network part. Let's talk about routing. Let's talk about how an IP packet or data gets from here to Australia. In the last video, I showed that a router is responsible for forwarding IP packets hop to hop. And the router does that by looking up the next hop address in its routing table. So the packet gets from the source to the destination. The router looks at the destination IP address of the packet and looks up the next hop in its routing table. But not each and every router is under a different administration. There are internet service providers, carriers, and they all operate not just one router, so most of the time a couple of routers. And this group of routers is what we call, a bit simplified, an autonomous system. So an autonomous system is invisible to the outside world. The inside of an autonomous system is kind of invisible to the outside world. The only thing the outside world knows about an autonomous system are the prefixes they are announcing. So this provider here on the lower right is announcing 3 prefixes and tells this to other autonomous systems. And for this, they are using a routing protocol called BGP, Border Gateway Protocol. If you are really interested in BGP, have a look at the DE-CIX Academy website, where I offer also a training about BGP. But this is networking basics. So very simple, an autonomous system is a group of routers announcing prefixes to the outside world, to other routers. But how did all this start? A little bit of personal history also. Internet in the 1990s. 2 megabit per second was considered to be a very fast connection. The backbone we had at this time was 34 megabit per second fast. And end customers, like home users or businesses, were connected with ISDN telephone lines having a speed of 64 kilobit per second. So really, really slow in today's terms. In Germany, we had 3 commercial internet service providers in the 1990s. And each of them, they had a connection to the US via a transatlantic circuit, which was really expensive. And they were not interconnected between each other. So all traffic going from one end to the other had to go via the Atlantic twice in worst case. And like I said, that was very expensive. So we had an idea. Why not exchange traffic directly? Well, one way to do that is via cables. And unfortunately, each of these early ISPs was in a different city, and cables and leased lines were extremely expensive. And so the idea was born, why not meet in the middle? And DE-CIX was born. This was the idea behind DE-CIX, the German Internet Exchange. Interconnecting commercial providers directly. So each of us bought a circuit to Frankfurt, and there we interconnected and started exchanging traffic. Of course, only our own traffic and the traffic of our customers. And this was called peering. The formal definition of peering, according to Wiktionary, is the art of carrying communications traffic terminating on one's own network on an equivalency basis to and from another network, usually without charge or payment. And this is what peering still is today, exchanging traffic of similar sized networks, usually without charge. Let's have a look at a typical internet service provider. Here, the blue one, all kind of customers, domestic businesses, mobile, and so on, and connected to the outside world to 2 so-called upstream providers. Other ISPs delivering internet connectivity to this provider. And these upstream providers, they also are connected to other providers. The picture is a bit simplified. Usually, if you have a redundant connection, you will not let it end on the same router, but you also have multiple routers. Adding another ISP, here the green one, also has connectivity to an upstream provider, which is interconnected with other providers. So a simplified picture of the internet like it existed and still exists. To transport data from blue to green, in this case, we need to go through one of the upstream providers and to their upstream provider, down to the upstream provider of the green ISP, and finally to the green ISP. Well, that can be done easier. Just interconnect the green and the blue ISP. And now traffic can go the direct and short way between blue and green. This is the advantage of peering. And peering happens on multiple levels. Like the blue and the green provider are interconnected, so are their upstream providers. And also these two top-level providers here are interconnected. If you draw it a little bit different, you find that there is a kind of a hierarchy of peering. And peering usually happens between equal-sized or similar-sized networks. But it happens on all networks levels, on the bottom and on the top. The top providers, the so-called Tier 1 networks, they only peer with each other. And the definition, the formal definition of a Tier 1 network is a network which only peers, which does not buy upstream from anyone. And this is quite an exclusive club. If you're interested and who belongs to that club, well, have a look at Wikipedia. There is usually a list. So why does peering make sense? In the early days, peering was, of course, cheaper than buying upstream and buying transatlantic capacity. And it kept traffic going over the Atlantic twice. Today, well, upstream prices are down, but peering, well, it's still very important because it's keeping local traffic local, it's keeping the latency low, and also it helps the provider to control their traffic. They can always steer their traffic over peering or upstream, and like it is best for different criteria. Where is it cheapest or where it has the best and lowest latency. And an internet exchange helps to facilitate peering by offering a meeting place for multiple providers, for a lot of providers. For example, DE-CIX Frankfurt has more than 1,000 peers. So if you want to peer, well, of course, DE-CIX is the place to be. This is the DE-CIX Academy. Good. Conclusion. What did we learn about global IP routing? First, about prefixes. Networks, internet providers, they announce IP prefixes. And with this announcement, other providers know where to send traffic. IP packets are routed to these prefixes using their destination IP address. Peering, new term for today, is the exchange of traffic between similar-sized network, most of the time settlement-free. In the past, peering was mainly done to reduce cost. Today, peering helps to decrease latency and to get traffic to your destination faster. Also, it enhances control for networks who peer. And internet exchanges like DE-CIX are places where a lot of providers meet to exchange traffic. That's it for today, and thank you for listening. I'm Wolfgang Dremmel for the DE-CIX Academy. Thank you and bye-bye.